Okay, so hello and welcome to the week 6 tutorial problems for the machine and mechanism A. We're going to have something like 4 questions. I'll try to actually cover as much as possible of them tonight, and I promise you to send the rest by tomorrow. So we start with the first question, which is about the lady that sits on in a rigid position on her rocking chair by keeping her feet on the bottom at the rung at B. Her feet is here. Now, bear in mind what will be the forward angular acceleration alpha and the frictional force at the point A necessary. So point A is here. Well, actually need to use a laser. Okay, so the point A is going to be here. The friction force is going to be in this position. Try to prevent the chair from sliding into that direction. So we need to find what will be the alpha and the frictional force at A necessary to prevent the rocker from slipping. Of course, the friction force is going to be equal to normal force multiplied by the coefficient of friction that we don't know what its value is. The normal and the rocker, the woman and the rocker have a combined mass of 90 kilograms and rate of gyration about the point G of the kg equal to 0.45 meters. Now we know that we can find the value for the Ig by using the kg and the mass. Okay, now remember that. Now we need to analyze this situation into both the free body diagram and the kinetic diagram. So we start with the free body diagram. It's going to be the mass of the chair and the lady going downward at the point G. Okay, so this will be equal to total mass multiplied by 9.81, and this will be 882.9 Newton. The location of the point G from the point A is going to be 0.48 meters vertically and horizontally about 0.2 meters. The point A here is going to have normal force and A upward, and the frictional force going to the left or right. We can find that actually by the side later at the point A. Now in the kinetic diagram, you can see that we are going to have mainly the mass multiplied by the acceleration multiplied by um, uh, the, the distance from G to A, RGA. Okay, well, away from this value, we're going to find the correct value. And for the acceleration, we're going to have the 90, which is the mass multiplied by the kg square multiplied by the alpha. That's the Ig alpha. Now, what we need to find actually, well, this is tangential acceleration. We can find this angle because we can treat that as triangle. And also we will find the horizontal component and vertical component of that acceleration. The distance from between the G and the A can be found because we can treat that as triangle, that we can find actually its angle and its dimension. Okay, now once again, we are going to have a triangle like that. Okay, so this is the RGA. We know this value, so we can find the angle here. We're going to use that to analyze this acceleration in two components. The normal acceleration is going to be 0 because the omega is equal to 0. So this will be the, after sketching the free body diagram, we're going to find the sigma of the forces in the free body diagram to the x-axis, which is going to be equal to the sigma of the forces to the kinetic diagram, which is going to be the mass multiplied by the AGX. And then for the y direction, the same thing in the free body diagram. We have the vertical forces here, which is going to be equal to the mass multiplied by the AG to the y direction. And finally, for the moments to the free body diagram about the point A is going to be equal to the moments around the point A in the kinetic diagram. And by solving, we will find the alpha, the FA, and the NA. So these are the figures we should get. And let's see how we get to get them. So first, we're going to define that the bottom rung is going to be on the arc as a section of the large circle. So the problem can be treated as a rolling motion without slip. So this is more detailed drawings for the free body diagram. That's the arc. Okay, we have the arc is here. Okay, that's the point A, friction force, normal force, the weight going downward, the distance RAG can be found is here. Okay, by solving for this triangle, the weight is going downward at the point G. For the kinetic diagram, at the point G, we're going to have two components for the force, which is going to be the mass multiplied by the acceleration G to the x direction. and the mass multiplied by the acceleration g to the y direction. And we have the IG multiplied by the alpha for the moment. And we can keep solving for that. So the known values we have is in the mass is 90 kilograms, the kg is 0.45 meters, the omega is 0 radian per second, and the unknowns are the force A on the x-axis, the friction force, the normal force at A, the alpha value. So we are going to start to do the solution. These are the set of the equation we're going to have. The sigma of the forces in the free body diagram to the x-axis is going to be equal to the mass multiplied by the acceleration to the x direction. The AY, the same thing, the mass multiplied by the acceleration to the y direction. And the sigma of the moments around the point A is going to be equal to the IG alpha plus the mass multiplied by the AG tangential multiplied by the RG A. This from the G to A. Now we start with the solution by calculating the RG, which is going to be equal to the mass multiplied by the kg square. The kg was 0.45, so 0.45 square multiplied by 90, and this will be equal to 18.225 kilogram meter square. Now the distance from the G to A can be calculated by using the trigonometry of the right angle triangle, and it's going to be equal to the 0.2 square, which is the distance to the x-axis, plus the distance to the y-axis square, all under square root. Solving that, we will find that the answer is going to be 0.52 meter per meter is the distance between here to here. Okay, so now we're going to go to the next point, calculating the accelerations. So the first acceleration is going to be normal acceleration along the GA, which is going to be equal to 0 because it's going to be equal to omega squared multiplied by the RGA. The RGA is 0.52, but the omega is 0, so this will give us a 0. Tangential 1 is going to be equal to the alpha multiplied by the RGA. RGA is 0.52, the alpha is unknown, so we're going to keep it like that. We're going to assume that the alpha is going to be positive, and so the AGT should be positive as well. Now for this acceleration, we can take it to the x direction and the y direction. So to the x direction is going to be multiplied by the cosine of theta. Okay, you know actually where theta is. Let me clean the image so it's going to be more clear. So that's the alpha we're talking about is here. So to take it to the x-axis, we need to multiply it by the, okay, now that's the acceleration we got. The alpha also going to be here. So take it to the x-axis, we multiply by the cosine of the alpha. Take it to the y-axis, we multiply by the sine of the alpha. Sorry, theta. So these are the two equations we're going to have. We're going to do that. And we're going to get the accelerations in the x direction and the y direction. This should be negative because they're going to the left and going downward. Now we start to do the calculation for the forces to the x-axis. So the friction force at A is going to be equal to the mass multiplied by the acceleration at the point G to the x direction. Or I can say that the FA is equal to 90 times negative 0.48 alpha. Now we said it's negative because it's going to the left acceleration. Okay, so that direction is not the most accurate one here. And actually those should be going to the other side. You can tell that because the acceleration is going to that direction because the whole thing is rotating to that direction. So we will find that the force A is going to be equal to negative 43.2 alpha n. We don't know what the alpha yet. So I need to solve for the alpha to find the friction force. If I'm going to do the calculation of the forces to the y direction, I'm going to come out with the same result, but now in the y direction we have the normal force at A, positive, and the W is negative. On the free body diagram, I have the mass multiplied by the acceleration gy. Remember that once again, this is a negative value. So we can write down the equation like that. We can put the parameters that we know in, and we are going to solve for that, and we will find the relation between the NA as a function of alpha, and this will be equal to 882.9 negative 18 alpha. Okay, so what we've done is simply that the value we have here should get the sign of negative, and this value will move to the other side. It will get a positive sign, so it's going to be 882.9 negative 18 alpha, and this will be equation 2. So still I don't have the alpha. Now let's go to another relation that provides me the value for the alpha through the solution, which is going to be the moment around the point A. Actually, it's going to be a nice idea to clear the screen, and then we're going to have a look here. Now, if I'm going to do the moment around the point A, it's going to be first on the free body diagram, the point A, the FA and the NA doesn't have any effects on the moment at this point. But the W is going to create a counterclockwise moment by multiplying W by the distance of point 2. Now, on the kinetic diagram, we have the IG alpha. We know the IG, but we don't know what the alpha is. And we have the RGA, and that's the tangential acceleration. So it's going to be the mass multiplied by the AT. Again, this one will take me to the counterclockwise, so it should be positive. So I can start to write down the equation here. All the parameters are going to be positive. So we have 90 multiplied by 9.81 times 0.2, the free body diagram, and 18.225 multiplied by the alpha. That's what we have for the IG alpha. That's the IG multiplied by alpha. And now this is the mass multiplied by the RGA multiplied by the acceleration to that direction. So 0.52 alpha. Now, the only unknown we have in this equation is going to be the alpha here. So we're going to solve for this equation. We're going to find the value for everything on the left side. Solve, and we can find that the alpha is equal to 4.15 radian per second square. Now solve for that. Put them in the equation 1 and the equation 2. In the equation 1, we are going to find the value for the FA to be equal to negative 179 Newton. And we're going to do the same thing for the equation 2. So the 4.15 radian per second times the 18, and then subtract it from the 882.9, we will get that the value for the NA to be equal to 808 Newton. So that's the first question, and I'm going to keep the questions streaming.